All right, so what's up?
So my only question is like knowing when we're working through the problem,
Mhm.
when do we actually convert like the static budget in order to do the flexible? Like what are the signs that would make me be like, oh, I need to do this conversion in order to do it? Is it only around like the quantity variance questions? That's it?
Yep.
If it's price, I don't even need to worry about it at all.
I'm 99% sure I didn't create any questions where. Yeah, I don't think you would even have the concern, because once you get past, you got your mountains. Once you've moved from the flexible budget to the quasi budget and gotten the quantity variance teased out, you're now in actual quantity land. So whatever the standard quantities are, whether flexible versus static, you're not even going to consider that in the equation for price. So yeah, it's really just there where I try to trick you in quantity variances. So that's the red flag that should shoot up. If it's a quantity variance question, maybe he's going to try and trick me and get me to use the static budget. Yeah, and so then I might need to convert the static budget into the flexible budget. Yeah. Good question, yeah. Okay, I'll get you all done. Here. Okay, so today let's keep moving on our module here, chapter 7, DMDL module. We'll look at a couple more questions at least, and then I'd like to start talking about next week's variances, because they're a little different out there. Specifically, if we can get some time talking towards the end of class about mix and yield variances. They're just a little funky. Overhead variances are kind of, you need to be precise in what you're looking at and the terminology when you see the questions, but it's the mix and yield questions that I think we need to spend time to get some of the conceptual groundwork down about what we're talking about. So both of them have a little bit of an elevated level of difficulty. I think these over here, the mix and yield variance questions, have they're just a little odder, and so I want to make sure we hit that for sure. All right, so let's go ahead and look. Any particular type of question giving you trouble? Wait, let me start out. There are at least 4 questions in the test bank that I made fixes to. A couple that were made aware. I was made aware of via email. Others that I was made aware of at the end of class on Monday that I made quick fixes to, and hopefully they show up. So if you have a draw of questions that came Monday or before, and maybe even Tuesday or before, because again, a couple of them were fixed over email, you might have some old questions that are weird looking. And let me know if it's like this question, I don't get the right answer or whatever, because you have one of those old draws from the test bank. Let me know, and I can say, oh yeah, that should say this, and solve the question that way, and you'll be able to choose the right answer. Or, if you're doing multiple attempts, which I think would be ideal, kind of designed to help you or incentivize you to have multiple attempts, so you're extra familiar with a variety of ways of asking the question. So when you get to the exam, nothing will catch you off guard. Then, of course, if you draw now, all 4 of those changes and fixes I've made will be in there. Okay. So any kind of question in this chapter that are giving you trouble, or this module? Yeah.
There are some questions on like direct material quantity variance, and they have actual direct material purchase and actual direct material.
Excellent. Okay. So the short answer is, we'll go over a question like that, but the short answer is, when we're doing the quantity variance, we're interested in the quantity used. Let's look at. Let's see if I can get. So this is a version of this kind of question, but it's asking for price variance. Yeah, let's go see if we can find something else. So this is asking for quantity variance. This is kind of like the question you're a version in the ballpark of different numbers. Okay. Well, let's give this a shot, and just to see where we're at. So we're looking for the direct materials quantity variance. So kind of a pretty straightforward version of this question. I don't have to do any crazy algebra or anything like that. So I can go and think, either remind myself, or what I do is I track down the breadcrumbs, because I know all the little principles, and I rebuild the variance analysis every time in my head fresh, which is bad programming if you're doing it like you're a programmer. You're like, well, no, you want to automate that. For me, I don't trust myself, so I make sure I know how to do it. Okay, so I know I need to get quantity variance That's here in the mountain chain, not over here. So I'm going to be going from flexible budget standard to quasi budget, and so I'm going to be doing standard price on the outside of the parentheses, and then inside the parentheses, I'm going to be comparing some actual quantity minus some standard quantity, because I know that inside the parentheses, that the difference here is what's going to give me the name of the variance. That's the lever I'm pulling that I'm comparing. That's why that number is going to have the meaning that it does, because I'm comparing quantities. And here, the reason why we're going to use the actual quantity used, I don't think I actually laid out the rationale fully when I went over that really quickly Monday or last Wednesday. But the rationale in part is the slippery fish thing. People are going to avoid responsibility. And you want to put at somebody's feet a choice that he or she has control over. Nobody likes, you wouldn't like it if I said, well, your grade today depends on whether I can make my commute in normal time after I get home or on my way home today. You wouldn't really like that, would you? Because my commute home is in the hands of all the crazy drivers on the road, and you have no control over that. You wouldn't want it to be, well, I'm going to decide your final grade based on whether it's raining that day or not. Okay. Again, you don't have any control over the weather, I hope, otherwise you have some answering to do. But you don't have any control over the weather, so you wouldn't want that. Likewise, when we're doing the variance analysis, the idea is to get to a point where we have enough information to ask the right questions so that we can improve performance in the future. Get more favorable variances. If we got favorable variances this period, continue that. Or get fewer unfavorable variances. If we got unfavorable variances this period, to discontinue that into the future. We want to ask the right person those questions, lay it at that person's feet. So the person who is determining price variances, not this question, but price variances, direct materials price variances, direct labor price variances, is the person who's purchasing that input. The person who is in acquisitions, the person who is hiring in HR or whatever, determining wages in terms of direct labor. And so in direct materials here, we want the purchasing who is in purchasing, the person who is in purchasing, the purchasing manager who has control, what he or she has control over, to be the number we use to determine the variance we're going to lay at that person's feet. So I don't want to give the purchasing manager an out and say, well, we calculated your direct materials price variance using actual quantity used, and here's the number. And if that's the case, what will happen is the purchasing manager will come back and say, oh, well, you know what? A lot of that is driven by the fact that in the factory they used a weird amount. They have a little bit of an out. I don't want to lay at the feet of the purchasing manager a decision that was made on the factory floor. The actual quantity used, that's a decision made at the factory floor. Actual quantity purchased is made by your supply chain purchasing department. So for price, I want to use actual quantity purchased, because I'm going to go take it to the purchasing manager. For quantity, that's usually almost always a question of what happens on the factory floor. So actual quantity used, I'm going to take that to the production manager and say, you're in charge of what happens on that factory floor, and you have control over the actual quantity used, at least directly and or indirectly here. So we're going to use that number to figure the variance, the quantity variance we're going to lay at your feet. So it's about the people as much as anything else, why we do it. So that's a big long spiel about why. Ultimately, the point is that this equation for DMQV, quantity variance, is actual quantity used minus standard quantity, which is the standard quantity at the flexible budget, total standard quantity at the flexible budget. That difference multiplied by standard price. All right, so let's look at this question and apply that. And it shouldn't take too long. My spiel won't set us back too far. So we know we're going to need DM quantity variance. I think I have to turn on numlock every time. Question. We are going to just write out my equation here. AQU minus SQ times SB. And that's going to equal the DMQV, direct materials quantity variance. All right, so in the question here, we just copy down. We have actual quantity used and standard quantity and standard price. Actual quantity used, they give us 87.50. Standard quantity, let's leave that blank for a second. Standard price is 10. So we have a standard quantity per unit given here. So we know that we should use 5 direct materials units per finished goods unit. And here down here is where I'm tempting you and saying, basically that the static budget amount for finished goods units was 2,000. We budgeted 2,000 finished goods units. Our actual volume, our actual production was 2,400. So which of these two do we multiply the 5 by? 2,400, exactly. Yes, thank you. So this is going to equal 2,400 times 5. If we knew now, what we know now, and we got in the time machine, we go back and we're top into the budgeting meeting and we say, hey, it's going to be 2,400 finished goods units. We would have budgeted 12,000 direct materials units in that case. So we have actual quantity used. I'll put the parentheses in. Actual quantity used minus standard quantity all times standard price. We're just following the equation we copied down. And that should be our direct materials price variance. Excuse me, quantity variance. Misspoke. Okay, it's a negative number. If you've gone with a sign, that means it's a favorable variance. You can also double check that with the logic. Okay, well, the more actual number was lower than the less actual number. So given production of 2,400 finished goods units, we used way fewer units of input to get those finished goods units than we thought. That's good. That's to say as efficiency. Sometimes this is even called the efficiency variance in some circles. It has 3 names: quantity, usage, and efficiency that are commonly used. Efficiency sometimes is only used for the direct labor version of it. Anyway, so this is a 32.5 favorable variance. All right. Does that look pretty good? Hayden? Okay. So I don't know if this 50,000 comes from us making this mistake, multiplying 5 by 2,000, or if it comes by us using AQP instead of AQU. I don't know which one, but one or the other will give us the wrong answer. Yeah.
The math, maybe we went over this in past class, but the math change whether we're doing it for direct materials versus direct labor, or is it all kind of the same?
The math doesn't change. Just with direct labor, AQU is always equal to AQP. So there's just one actual quantity. So with direct labor, you can't purchase hours of people's time without using those hours of people's time. It's not how time works. So direct materials is the only way you can have a difference in AQP and AQU. But the equations themselves don't change. Just there's only one AQ as a result with direct labor. Yeah.
So if we were doing price variance on this one, we would just substitute AQU for AQP?
We would use the price variance equation, and for AQ, would do AQP. So price variance equation is the price variance equals the actual price minus the standard price, and then we're going to multiply that by AQP is the idea. Yes. Now. Okay. All right. Probably takes between 1.77 and 2.34 hours to get real familiar with the equations. Yeah, and I made those numbers up, but yeah, around there, I don't know, 1 to 3 hours of time in the quizzes to get pretty comfortable with the equations, and then you're pretty rocking and rolling, and those basically solve the problems. The last component is interpreting the word problems, the story problem here, into the different AQ, SQ, AP, SP, etc. Occasionally, I have some tricky stuff there. Okay, we did a direct materials question.
Can you do one where it's the quantity was you have to convert it from the static budget into flexible and then?
Yeah. Let's see. I wonder if I just rolled upon this. Let's see. No, this isn't it. Let's see if I've got one that's like that. I have a direct labor quantity. So I think this one will be one of those, because I have a bullet point about static budget, finished goods units. What do I have? Sorry. Actual finished goods units and standard direct labor hours. No, this isn't quite. So you're saying I'm given the static budget, standard quantity at the static budget, and I have to infer from that what the standard quantity per unit is, and then multiply that by actual volume to get the standard quantity at the flexible budget. Yeah. There are some questions like that. So let's look at this. Maybe we hit gold here. Let's see. So this gives us standard direct labor hours on the static budget here. And then we would divide. Yeah, I think we can do this. This is a question that will have that aspect to it. Okay, so ultimately this question is asking for direct labor quantity variance. So this is open answer, direct labor quant variance with a static budget aioli. Yes, I'm trying to entertain myself because otherwise I get really bored. So here we go. We need to figure out our quantity variance. Oh, wrong screen. Ha. And our quantity variance is going to be the same as up here, just that we can get rid of the U because we know it's going to be AQ is AQ is AQ with direct labor. But it's the same equation ultimately, AQ minus SQ, and that difference multiplied by SP. And we can start to take some of these. We have AQ, SQ, and SP. Looks like our standard price is the wage per hour here of $10.77. Great. Our actual quantity of direct labor hours, there we go, 22,900. And standard quantity is when we're going to have to do some calculations. So here we have our standard quantity on the static budget. Right here. Great. We can't use that yet. And our finished goods units that we used to get there on the static budget is this 11,946. So the ratio or relationship between these two numbers will tell us what our standard quantity per unit is, our building block of building expectations about the future. So we can take and divide. So basically, per finished goods unit expected, we expect 1.77 direct labor hours. Okay, well, we can then take our actual finished goods units right here. I'll drop a little further. Actual, how did I phrase it before? Finished goods units and then parentheses actual, make it parallel. Okay, and we can multiply those two. And this should be our SQ at the flexible budget, not the static budget. So this is, sometimes I omit this and it gets people, sometimes when I put it in, it helps. We're playing between standard quantity on a unit basis and standard quantity on a total basis. So this is the same no matter whether you're talking about static budget or flexible budget. The SQ per unit is always 1.77, 147, et cetera, et cetera. It's a question of the total standard quantity because that number here, that 1.77, gets multiplied by either the static budget's finished goods units or the actual number of finished goods units. So these two differ, the SQ total. And every time we have SQ in here in the equations, it's always, well, it's in the quantity variance equation, excuse me. The time we have SQ in the quantity variance equation, it means the total standard quantity. So we're trying to get the right total standard quantity right here. So let's just program in AQ minus SQ times SP. I think we follow that equation. We followed the equation and copied over information right. That should be the right answer for us, I think. Does that make sense what we're doing? Okay, good. Yeah. Because there's a decent percentage of you who have still have good familiarity from introductory classes, I tend to put a few more wrinkles into these kind of questions, make you really get a few extra reps here in a pretty simple exercise for you to build up the mental strength on this. So yeah, I try and trick you a little bit more here than typical quizzes. Okay. Yeah.
We could go over a direct labor quantity variance question.
Other than this one here,
Yeah.
we've got we have this one. It's another open answer, but it might be pretty similar to what we just did. What do you? Is it good? Do you want to go over this one though?
Yeah, just one without like the static, just budget where you added it. Just want to go through it straightforward.
Okay. Let's see. Is this one kind of straightforward? You tell me. Do you want to try this one, or let me keep looking for one that's even more straightforward than this one? Okay. All right. Awesome. All right. So this is with al natural, we'll call it. Is that al natural? Al? Whatever. All right. So we have the same equation. We're going to try and get the same information. We just don't have to go through all the pains here to figure it all out because I give you the standard quantity per unit right here. So we just need to do this piece right here. Relatively simple to do it. So let's grab. We just need to define these three terms. Actual quantity used. Oh, looks like we got that. 624. Standard price. Looks like we got that. 4.5. And the standard quantity is going to be our 0.5, just right here, standard quantity per unit, times the actual units produced, 1032. So that should be relatively straightforward. We got, oh, put the parentheses in. No, not base. Parentheses. Actual quantity minus standard quantity all times the standard price. Right? So that should be our direct labor quantity variance. That should do it, I think. Does that look good? Okay. And if some questions, I'll just give you the total standard quantity of the flexible budget, and then you don't have to do even that multiplication inside the cell here. Yeah, I see a hand over. So I think I saw you first, yeah.
I was going to ask, you're making a journal entry for price variance.
Mm-hmm.
What is debit and what is credit?
So for all the cost variances, which is what all this quiz is about, and the next quiz, they're always, so the variance account is an expense account, and more expenses is unfavorable compared to less expenses. So they go up with a debit, unfavorable variances get debited to the variance account. I don't think I said that as clearly as I've said in other times, but yeah, if that clicks enough for you, then that's, yeah.
So I do have another question about PVC piping. It gives like an amount of PVC pipe purchased and used, a standard quantity PVC pipe, standard price, actual price, and then it asks what was the debit to WIP for direct material.
So here's a version of that question. I don't know if it's the exact same numbers. Okay. So we can kind of sidestep a little bit of this information by remembering the rule of thumb with standard costing. So with standard costing, when we're debiting to work in process, we're going to be debiting at full standard. That's kind of the rule I'm testing here. If you're remembering that rule of thumb. Whatever we debit to WIP, it's going to be at the full standard. Standard quantity times standard price. So we really just need to know this business right here, and we need to know standard quantity and standard price. Those two right there. So those two multiplied would be the answer to this question right here. 475. So this is debit to WIP question. That's fine. 475 is our standard quantity, and 5 is our standard price. So we just multiply those two. Yep. So this, what it's asking for, makes it a pretty simple question. The trouble is when you're if you don't remember, this is the rule of thumb. If you don't realize that's what I'm trying to ask for, then yes. This is the sea of red sea. Yeah, red herring sea. Sorry, I'm not on my game today. This is pretty bad. Did I see other? No more hands? Okay. 7-1 is due on Friday. I'll pause for another few seconds here in case I really want to ask that question. I'm not nervous. Professor's been known to throw things. Decide whether you want to ask the question. But if I don't get anybody wanting more 7-1 questions, let's talk about 7-2 stuff. Okay? All right. Well, first let's make sure I didn't screw anything up here, which is very possible. So I answered 4 of the 10. So I should have 10 of 25 points. That sounds right. 2.5 points per question times 4 is 10. Great.
Width is always standard.
Mhm.
The variances are always actual.
The payables, whatever the payable is always actual. In my example in the textbook, I have it to an expense account, which is passing through to the payable. But the ultimate idea is the bottom line credit that you're crediting is always going to be at actual. You want to recognize that decrease of an asset or that increase of a liability at what you actually owe. Okay. All right. Get that. Okay, so like I said in the textbook, I don't think this is too bad of a section here. Specifically jumping over overhead costs, going and my little trying to tie everything together to justify my life as a professor here. In 7.7, but instead 7.8, mix and yield variances. Let's talk about this. And I paused for a second. I think Chase asked the question about going up, and I said cost variances, which is all we do in 7-1 and 7-2. And I paused because there is a chance that you will see a sales mix question. I'm trying to remember if I have many of those. Because there are revenue. This is the one place where I'm going to potentially test you on some revenue variances because they might be mixed. I'm trying to think about the test bank and try to recall what I have in there and what I don't. At the very least, the vast majority of the test bank deals with mixed variances that are over here. Direct labor mixes and direct materials mixes. The point is that, especially in a modern business, it's very unlikely that you're going to have just one type of direct material, one input, or one type of labor. You probably have cross-functional teams and lots of people working on it. And to a degree, you might have some flexibility as to the mix of those different inputs. So you know what? When you're an auditor, let's say, your company can potentially mix in different amounts of people's time. You might have one account and you decide we're going to put a lot of low-level people on this one and very little senior or manager or partner time. Other ones, hold on, let's put more upper-level time on that. So that's a labor mix. Those are all direct labor that are going in, quantities of direct labor that are going into serving this account. But obviously, partner time is unequal to junior associate time. They come at different rates to the company at the very least. You can make your various jokes. Partner time is smellier or whatever. Yeah, go ahead. But the point is that they charge more per hour. That's ultimately what we're talking about here. And so, if you have 10 hours on the account, just to make it real easy, and 9 of those 10 hours are partner time, obviously you have spent more direct labor cost on that account than if it's reversed, and 9 of the hours are junior associate time. So some of your variance could simply be, in terms of how much your inputs cost you, could simply be a bad mix, a less profitable mix of inputs that are substitutable like that than you had budgeted. So you still, let's say, you budgeted 10 hours, you got 10 hours. It isn't immediately obvious that there's a potential variance in cost there. But if 9 of the 10 are partner hours and you budgeted 9 out of 10 being associate hours, that's costing you way more. And why? The mix. So the mix variance, it's going to have, as its lever it's pulling, the standard mix versus the actual mix. That's the lever it's pulling, and everything else is held constant. So that we say, how much of our quantity variance is due to the fact that we poorly mixed, or maybe we did it really efficiently mixed the inputs that are substitutable like this. Direct materials is the most obvious one, but I went to direct labor because it's first in the bullet points and because it's probably more relevant to more of you, more of us going to service and knowledge work among people who are in here than in the past, in this class, than was true in the past. But direct materials, actually, visually, I like that better because it's easier for me to think of a vat of chemicals. Liquid volume, it's incompressible, generally speaking. So you have a gallon, it's a gallon. And you have a gallon of chemicals. If you mixed in, let's say your standard mix is 50-50 for expensive chemical and less expensive chemical in that gallon. And somebody, Lucille Ball was on the factory that day and she, happened to lean on the expensive chemical button a little longer than she should have. And you have now 70% of the gallon is expensive chemical, 30% of the gallon is less expensive chemical. Oh yeah, you have spent way more on that gallon and it's because of the mix. So mix is trying to pull out this difference. You can conceptualize mix two ways. One is that the parentheses right here are here. So for every input, they have an actual input quantity versus a standard input quantity. So we expected 70%. That was a standard input quantity, 7 tenths of a gallon to be our input in this a gallon. And our actual, I said it opposite. 5 tenths, half of the gallon was supposed to be, so 0.5 gallons was supposed to be the standard quantity for our expensive input. Actually, we had 0.7 gallons of input for that. And we multiply that by the standard price, which is high for that input. And then we do this summation. If you haven't seen Sigma before, I haven't seen it in a long time, this is summation. So we go through each of the different inputs and we sum them. And so the nature of that is that the things will offset inside the parentheses, but the prices will change what happens overall to the cost. That's a complicated way of saying what I said earlier. You've got a more expensive set of partner hours or chemicals going in. The other way to conceptualize it is this table right here. And frankly, I think primarily when I solve them in class here, we'll do the table version of these questions. I just seem to like setting up this way better. So the idea here is over on this side, we have our actual mix, and we're going to subtract away from that over here our standard mix. And there are a lot more columns than just the mix. But notice that actual total quantity, all inputs, is the same, held constant on both sides. This is the one thing that changes. Actual input mix is here. Standard input mix is here. Mix is here. Standard price is also held constant on both sides. And so, again, the only thing we're changing is this column right here. But for me, I like laying it all out to make sure I've got everything squared away. If you're able to mentally, especially since a lot of the questions just have two inputs, so it's probably able to be mastered. If you're able to mentally offset them in your head, good for you, more power to you. That's great. I'm probably going to chart them all out when I do the questions. So we have a total number of inputs. So we have 1,000 in this example. 1,000 inputs. That's the sum of input 1 plus input 2. We have 1,000 gallons, 1,000 hours, or whatever. That's the total. And we expected 0.25 or 1/4 of them to be input 1 in this example. And input 1 is at a price of $15. Okay, so 1,000 inputs, 1,000 hours or gallons or whatever it is, times 25% of them, that's the mix, times $15 gives us, we should have spent $37.50, that was our expectation anyway, that's standard, dollars for input 1 given 1,000 hours of input, 1,000 gallons of input or whatever. And at standard, we took input 2, our actual of 1,000, multiplied by the 0.75 here. That's what we expected. 3/4 of that 1,000 should have been, based on the standard mix, input 2. And it's only at $10, so it's the cheaper of the two inputs. So we would have expected $7,500 of input 2 in our mix. So this is our standard price, our standard cost, standard cost for this type of input. Again, direct material, direct labor. Our standard cost for 1,000 hours or 1,000 gallons of whatever the input is $11,250. Okay, now we'll go back over here. We have the same cells everywhere except for here. Input 1, well, we actually put in half of our input. Half of our total inputs here are input 1 at $15 an hour. We actually spent $7,500 if they're priced at standard price anyway, because of our mix error. And we actually, based on the mix, would have had spent $5,000 on input 2. So total, that is higher. Right here, $12,500. All right, you take the two, you subtract them away, you get down here, and that's the mixed variance. That 12,500 minus 11,250 is a total of 1,250 unfavorable variance. It's E5 minus J5. That's our mixed variance. Great. Now you can do that with revenue as well. A lot of firms have multiple ways in which they can get referrals, business. You have a certain amount of cost for each of those different paths people can get to your business, and so it's worth looking at those variances a lot of times. I don't think it's a focus of the quiz. I'll have to double check to see if there's anything about sales variances on here that really make you think too hard about it. But there's another way in which you can have a mix of inputs. Now we are just to verify here. Where are we in the mountain chain? We're right here. So we're splitting up quantity into a yield variance and a mix variance. So it's always a quantity variance that we're mixing, or we're splitting up into a yield and a mix. And we only do it because we have, I think I said it exactly, I implied it later, but when we have substitutable inputs that operate in some sort of a mix. Different types of hours, different types of chemicals, whatever the case may be. I think I have a trail mix example in some of the questions. You get a little bag of trail mix. You can either have it the usual way, which is not the yummy stuff, or the really cool way, which is like, oh, you happen to get all M&Ms in your trail mix. It's a trail mix. So as a result, yield variances, there's a way of thinking about yield variances that works. But if you prefer, you can just think of it like, well, it's the leftovers after we chop out the mix variance. It's like the quantity variance after we've accounted for mix, or since we're going to be accounting for mix. It gets a little hairy. We've got some definitions in this equation and a really important flip we have to do. So yield variance equals, look at this. This is just stereotypical setup here. We have a parentheses with the thing we're varying, the one lever we're pulling, being subtracted away, actual minus the standard. So actual yield minus standard yield, and all multiplied by a price. And it's got a big long name, but we'll get there in a second. It's a standard price ultimately, a standard price. So we're going to define each of these. Actual yield is the actual finished goods units completed. So sounds like actual quantity, right? Sounds like it. It's not. It's actual finished goods units. Actual quantity throughout 7-1 has meant actual quantity of direct materials or actual quantity of direct labor, the input, not the output, which is finished goods. Yield flips that and says, well, we're talking about, since we're going to deal with all the substitutable inputs in the mix variance, we're going to measure actually how many finished goods we produced given that mix of hours or chemicals or whatever. So actual yield is the actual finished goods units completed. Standard yield is the finished goods units you would have expected given the total actual inputs at standard mix. So you calculate that with this little equation right here. Standard total output divided by standard total input times total actual input. Okay, so let me put numbers on that. Let's say, for example, we would have expected 100 pounds of trail mix inputs to yield 1,000 bags of trail mix. That's what that is. Well, we have 100 pounds of, what did I say? 1,000 pounds of, did I say it? 100 pounds of inputs right here divided by, no, 1,000, there we go. 100 pounds of inputs, there we go. All right, I'm getting there. Divided by our expected output, 1,000 bags of finished goods here. So that's 10 to 1, 10 over 1,000 over 100, 10, times the total actual input. So we typically, so let's say we have got 10 to 1, and then we have 2,000 pounds we put in. Okay, well, we'd expect 20,000. That's our standard yield. We expect 20,000 bags of trail mix given the ratio I set up and the 2,000 actual inputs that I told you about. Okay, so if we actually yielded 24,000 instead of 20,000, we yielded a lot more than we expected. Okay, we'll come back to that in a second. Maybe that set off some alarm bells in how I said that. to you, but let's come back to this last one. Standard price at the standard mix. All right, so what we're saying is, given a single finished goods unit, so like one bag of trail mix, and assuming the inputs are all at the standard mix, so we have the standard amount of peanuts, the standard amount of M&Ms, standard amount of whatever other grainy fluff they put in there that's not yummy, all at the standard prices for those inputs, that's the price we would expect to pay for that bag's worth of inputs. That's the standard price at the standard mix. This is why I put it over here. So we're still a standard mix. So here we're just talking about finished goods yielding at the standard mix. Then we're going to move a little further, and then we're going to move it to, oh, by the way, now we're talking about from standard mix to actual mix, and then everything else moves forward from there. So I phrased it the way it actually is here. I said, oh, we yielded 24,000. Our standard yield was 20,000. My little example, I threw out numbers floating in the air. I don't have anything written down. I know it might be confusing that way. But if you said just before 20 minutes ago, before we started talking about this, and I said, well, the actual was 24,000, the standard was 20,000, do you think that's going to be a favorable or unfavorable variance? Just using your instincts from 7-1. Sounds unfavorable. 24,000 with the actual, 20,000 what we expected. Sounds like we use way more. 7-1 is on input terms, and mixed variances are also on input terms. Yield variances are on the output terms. So you're going to have to reverse your logic for favorable and unfavorable, and the signs as well, for your yield variance. Given that we got 24,000 bags out of those inputs, when we expected to only get 20,000 bags, that is favorable. Now we have moved up in finished goods units that we produced from the number of inputs given. So that's a positive, that's a favorable variance. And so it would be a positive variance because in the parentheses here would be positive, 24,000 minus 20,000 would be 4,000 here, times whatever the standard price at the standard mix is for a bag of trail mix. So we'd have a positive yield variance. And for yield variance only, and revenue variances if we have any questions like that, but really in this case, yield variances only, that's a favorable thing. Positive is favorable in yield variances. Okay. So let's look at a question or two. Let's at least do one mix and one yield question. So we're just talking about yield, so let's go to yield. Let's make sure we get a yield question in here. Oh, there's yield variance. Let's see. Oh wow. Look at that, man. I'm really playing with the defense here. I got 2 cannot be determines. That's no fun. Well, let's go for it. And if we can't solve it, I'll tell you why. We'll figure out why, right? All right, so at the standard mix, the standard price. Oh, that sounds a lot like right here. Looks like I'm about to give you this number. The standard price at the standard mix per finished goods unit is $150. Also known as the price per batch. Did I say that in here somewhere? Some standard price of a batch of input units. Great. But the point is that this is the number we're going to multiply what's inside the parentheses by. Great. So let's grab our. So this is 7-1. We're going to go 7-2. Okay. This is our yield variance question. And our standard price at standard mix is 150. Great. Professor was nice. He gave it to you. Gave you the number right off the bat. All right, and the standard number of input units per finished goods is 4. All right, so inputs per finished goods unit, 4. If I could type it. All right, so we're going to need that. Oh, scroll down. We're going to need that for this point in the equation here. So standard output over standard input, we expect 1 over 4. We expect 1 unit of output, so 1 finished goods unit, for every 4 units of input. So that's what that represents. Standard number of input units per finished goods unit is 4. So we have every input unit will give us 1/4 of an output unit, a finished goods unit. All right. Now, the firm actually completed 4,000 finished goods units and used 20,000 input units. All right. So 4,000 is our actual yield. 20,000 is our actual inputs. So yield variance equals actual yield minus standard yield times standard price at standard mix. Great. We have two of those. We have actual yield. We have standard mix. We can expand this. So let's see standard yield equals our standard output units over standard input units times actual input units. So the point is that we have this ratio of output to input units. We're going to multiply that by our number of input units here. And that should be the number of outputs we should have gotten given our actual number of input units. In this case, we actually used 20,000 input units. So given 4-to-1, we should have had a standard yield of 5,000. Okay, aside from terminology, aside from all that, does that make sense? We have 20,000, we don't know what this is, 20,000 pounds of chemicals going into bleach bottles or whatever. We should have yielded, since it takes 4 gallons, gallons or pounds, whatever, 4 gallons to go into one bottle, it's a mega bottles. We should have yielded 5,000 bottles of bleach, 5,000 bottles of these chemicals. That's our standard. Okay, what do we actually do? The actual yield. So before we get any calculations, does this look favorable or unfavorable? It's unfavorable. I think I heard both out there. Your normal instincts for 7-1 is, well, actual is lower than standard, so clearly it's going to be favorable. Yeah. If you're talking about number of inputs or the price of those inputs, yes, if the actual were higher than you expected, that's bad. Here we're talking about outputs. We expected to yield 5,000 outputs given our fixed inputs. We actually yielded lower than that. We didn't get enough out of those 20,000 inputs. So we have, put the parentheses, actual yield minus our standard yield, all times standard price at standard mix. So looks like we can indeed solve this. That was a double blitz fake whatever play there on the answer choices. It doesn't matter that we don't know the actual mix of inputs because that doesn't factor into yield variances at all. That's on this side of the mix variance. Mix variance is pulling that lever from standard to actual mix. Yield variance is over here, still in standard mix land. Standard price at the standard mix is right there in the equation. Okay, it doesn't matter. Let's see. Cannot be determined because we do not know the standard mix of inputs. It doesn't matter that we don't know the standard mix of inputs because I gave you what the price is at standard mix. I circumvented that. You would need that if you had to calculate it yourself, but I gave you the final number. So that's incorrect. All right, so negative 150,000. Oh, negative. That's always favorable, right? Now, in the yield case, remember, it's the opposite sign. So this is actually a favorable, unfavorable yield variance. Okay? So half of 7-2 is mix and yield questions, and about half and half are mix versus yield. So about a fourth of 7-2 is yield. So if it gives you trouble, don't worry. It's not like going to dominate your life. It's a small portion of the class here. With mix variances, let's look at this one right here. Oh, look at chemicals, said the Joker. Chemical mix variance question. So we're looking ultimately for the mix variance. And I'm going to build the table. So I know in the table I'm going to have actual total inputs. Inputs. I'm going to have actual mix. I'm going to have standard price, and I'm going to have a subtotal. And you know what? For this one, I'm gonna go ahead and just flip between the two because I need some width on this spreadsheet here. All right, so know this is the actual side. So we're going to subtract this section from what we're going to build over here, and we have chemical A and chemical B. We just have the two. We have A and B, just two chemicals here, two substitutable inputs. And we're going to have almost the same things over here, except we're going to pull that one lever. Standard mix is over here. Okay. I know I'm going to multiply across. We're just multiplying across. Hopefully that makes it easy for you to do these things. The tables are not too tricky. And these two have to be equal to each other. The actual total inputs is true whether you're talking about chemical A or chemical B. It's total of A plus B. So that's going to be the same. So I just pre-programmed that. So I'll type it in here. It'll automatically populate. It can't be different between the two cells here. And same over here. And I'm going to put a check figure in. Make sure I have my standard mix equal to 1. So these should be equal to 1 right here. Just make sure I've got 100% in the standard and the actual mix here. And then my mix variance, just setting it all up ahead of time, is this minus this. I forgot to total this. Okay, just summing those two. Okay, so let's start inputting our information here. So we have standard prices. In fact, are we ever going to use the actual price? Yeah, spoiler alert, I just ruined tricking half of you. Sorry. There's no point in 7-2 where you're going to do a mixed variance and use actual price. That lever gets pulled all the way over here. We're still all standard prices from here over. This is where you get to actual price at full actuals. Mix, it's stuck here. It'll never leave this orbit. So all these bullet points where I'm tempting you to do actual prices, these two actual prices, there we go. They're red herrings. So we need standard prices. In fact, let's go, you know what? Let me be more organized for once here. Let's just go through the table in order instead of like picking, I'm going to go random things here and here. The total actual inputs, what do we have? 3,000 A and 2,000 B. So a total of 5,000 gallons of inputs, which happens to produce 5,000 gallons of finished goods, but that's irrelevant to us. We just want to know chemical A and chemical B, the total inputs. Oh, where is it? There we go. It's 5,000. Okay, that's held constant. Great. The actual mix. Okay, so the actual mix, well, is that yeah, we're going to have to make decimals out of this. Yeah, 3,000 of the 5,000. Wait, is it chemical A? Yeah, okay. 3,000 of that 5,000 is chemical A. And 2,000 of that 5,000 is chemical B. Right. Standard prices, $4 for chemical A, $6 for chemical B. 4 and 6. Great. So we would expect we actually, given our actual mix, our costs are $24,000. Now, it's not the actual cost of our chemicals because we still have a number of standard things in here. We have our standard price. We have really what the actual total of inputs there is, the standard total of inputs. It's, let me step back. I'm not going to say that. We at least have a standard price in here. So this isn't necessarily the actual cost of our chemical A and chemical B that we used, but this is what we paid insofar as our actual mix is concerned. Whereas over here, our standard mix is to use 2A for every 3 gallons of B. So what we have is 2A, 2 out of the 2 plus 3 gallons. So 2 out of 5 should be A. And 3 out of 5 should be B. So we basically have reversed the two, our standard to our actual. And the standard prices are the same, 4 and 6. So there we go. Okay, look. We at the standard mix, we would have spent $26,000 on these chemicals. At our actual mix, we would have spent $24,000 on these chemicals. So we save money. I mean, I don't know if the consumer's going to be happy. Looks like they got something watered down with a cheaper chemical. They were supposed to get 40% of each bottle, each unit, each gallon of the chemical was chemical A, which is the cheaper of the two. Actually, they got 60% was the cheaper chemical in each gallon. Okay, for completeness, let's go ahead and look real quick at the other way of solving it. Just real quick. Won't take too long. You can also do this right here. So actual input quantity minus standard input quantity. And so we have chemical A. We have 5,000. No, we have 3,000 is what we, there we go, actual input quantity. And given 5,000 total inputs, and 2 out of 5 were supposed to be what we input, that was our standard. 2,000 is our standard input quantity. Okay, we have a standard price of 4 for A. So we just take the difference between these two. I put the parentheses in and multiply it by standard price. So I'm just doing this right here, actual input quantity minus standard input quantity times standard price, and that's for input 1, chemical A in this case. And we do the same thing again now for chemical B. Our actual input quantity was 2,000 units. Is that what it said, right? That's what chemical 3,000 chemical A and 2,000 chemical B. That's the actual, and we were expected to. Of those 5,000, we would have expected 3 of the 5, 60% of them, or 3,000, to be chemical B. So our standard input quantity would be 3,000. And standard price is 6. And we end up with the same mixed variance at the end. So let's say method 2, method 1. 2 different ways of getting it. So when I said earlier, real quickly, I said the insides offset each other, but then when they're multiplied by standard prices, it creates a problem. When we're talking about, especially when we're talking about just the 2 inputs, it does it very directly. We used 1,000 more inputs, 3,000 minus 2,000, more inputs for chemical A than we would have expected. We used 1,000 fewer inputs for chemical B than we would have expected. So those two literally offset each other. We used 5,000, which is 5,000, but 1,000 more of them were chemical A, 1,000 less of them were chemical B. Those two directly offset each other. The problem is that chemical A and chemical B differ in their price, and so that's what causes this difference right here. All right, so that is a favorable variance because it saves us money. We can use our normal logic from 7-1 for mixed variances. The actual mix led to a lower cost than the standard. That means it's favorable. Or if you remember the signs, negative is a favorable result. Okay, so that should be 2,000. Is that on one of the answers? $2,000 favorable. Okay, we just got 2 questions in. I'm going to check it. And I think that's where I want to stop after that. Let's check it real quick. We should have 5 points. Great, we got the 2 questions right. Okay, we'll have plenty of chance next week to talk about mix and yield. Again, do more questions. Just take your time with those questions when you get there. And we'll also have time to talk about overhead variances. And I think the questions that I have on the quiz are pretty straightforward, although they're just a hairy topic in general. Anyway, thank you.